Yeah, now, this is the slide that we are going to be using. This is the slides, the document that we're going to be using. The topic is work, power, and energy. It's for us in S2. Now we are going to start with looking at work. If you people are able to see what's on the screen and you are able to hear me well, I'm going to request one of you to read for me what you see. Yes, I'm seeing some hands up. Let me choose Bridget. Bridget.
Work. In physics, work is done when there is a force that acts on an object and displaces it through a distance. Therefore, work is defined as the product of force and distance moved in the direction of force. The SI units are joules.
Okay, thank you so much. You can now mute your microphone. Bridget has read for us that in physics, we say that work is done when there is a force. I'm sure by now, after our S1, we all know what a force is. We know what a force is, and we also know what are the effects of force on a body. For example, if you look at that diagram, anyone who can tell me that person doing, what is that person doing in the diagram? And which effect of force is going to happen on that box? Yes, Peyton? Peyton, you unmute, please, and you give me your answer.
The person is pushing a box.
The person is pushing a box. So what will happen to the box after some time?
The box will wear and tear.
The box will wear and tear. That is Python. Any other person?
Due to friction.
Okay. She's saying that the box will wear and tear due to friction. Yes, Bridget?
The position of the box.
Sorry?
Change in the position of the box.
So there will be change in the position of the box. Thank you, Bridget. Is there anyone answer? One more answer? Yes, Elizabeth? You unmute and give us the answer. Elizabeth? Elizabeth? I think Elizabeth is not there. Yes, Becky? Becky?
Causes unnecessary noise.
Becky says it causes unnecessary noise. Okay, thank you so much. I will ask all of you to mute your microphones, please, if you are saying nothing. Okay. You have told us that, yes, there is force and the effects. Someone told us change in position. The wear and tear is also an effect, and making necessary noise will also be an effect at some time, but we are going to capitalize on this effect, which is change in position. Now we see that man is forcing a box to move from one place to another. So that means that person is exerting a force on that box. And there, since there is change in position, the box is moving from one point to another. And between those 2 points, there is what we call a distance. Therefore, that's why they are telling us that when we are defining work, we say it is the product of force and distance moved in the direction of force. And its SI unit is joules. So if someone asks you to calculate work, you'll just write that a work is force, product means times distance. Now you have to make sure that force is in newtons and our distance is in meters. And therefore, the answer you will get will be in joules. That is the definition of work. Can someone read for me that slide, what we have on that slide? Second slide. Anyone? Technopop, I will ask you to rename your device, please. But your hand is up, you can say something. Technopop. It's not there. Zanita, you unmute and tell us something.
Rafa and Romeo are siblings. They are told to push box through a corridor which is 4 meters long. Rafa uses a force of 8 newtons and moves the box through 2 meters in 4 minutes, while Romeo used 60 newtons, but the box was not displaced. Who of these two should not be rewarded and why?
Okay, thank you so much, Zenita. We have a scenario there. We have 2 people, Rafa and Romeo. They are given some work so that after that work, they could be rewarded. Rafa uses a force of 8 newtons, moves the box through 2 meters in 4 minutes, while Romeo, I used 60 newtons for 10 minutes, but the box was not displaced. They're asking us who of these 2 people should not be rewarded and what is the reason for them not to be rewarded. Angel's hand is up. Angel, you unmute and give us your answer. Angel?
Yes.
Yes, tell us your answer. Angel? Angel, tell us your answer. Angel is not there. Martha? Martha? Martha, give us the answer. Okay, those people using the chat, you should use the chat for putting answers there. We'll greet each other later. Let us use the chat for writing our answers if we can't speak. Martha, your hand is up.
Excuse me, sir.
Yes.
Could you please put back the number on the screen? I'm not seeing it.
Okay.
But the answer is Romeo.
Engineer. Okay, our answers are there. Our question is there. Our question is there, and I'm requesting you people to give me answers. Please use the chat for any answers. And if you get a chance and you are selected, give me the answer from here. Yes, Martha?
The answer is Romeo.
And why?
Because he's using a let force and doesn't move in a distance.
Okay, thank you, Martha. Martha said that the answer is Romeo because this person does not move any distance. Now, the force would be okay if Romeo moved some distance, but they told us that the box was not displaced. That means the 60 newtons didn't move any distance. And remember from our definition, we had it that force times distance is what we call work done. So if there is no distance, that means there is no work. That means there is no work done. So our answer there is Romeo. Hope you are noting down some of these things as we discuss them, because we may need them later as we are doing our exercises. Yes, Angel, your hand is up. I don't know what you want to say to us. You have something, say it now. If you don't have, please lower your hand. All right, let us continue. So now we have examples there. We have examples. We have 2 examples, and I want us to go through them. And now, Jojo says she's not getting me. Is it that you're not hearing me well, or there is something that is missing? Jojo, is it that you're not hearing me, or there is something else? Please type what you are not getting in the chat so that I can read it properly. Hello? Okay, Jojo, whatever you are not getting is because your microphone is not on, according to what I'm seeing here. Your microphone is not on. So please first put your microphone on. You'll be able to get everything that I'm discussing. I'm going to request one person to read for us example 1 so that I can go through it. Peyton. Peyton, you read for us example 1.
Yes.
Okay.
Jen pulls a goat which is resisting to move through a distance of 5 meters using a force of 60 newtons. Calculate the work done on the goat.
Okay. We have an example where they have told us that there is a force of 60 newtons that is pulling a goat. This goat is resisting, and this goat is pulled through a distance of 5 meters. So they're asking us for the work done. Now, if you are to calculate the work done, we have to remember our definition. We said that work done, I'm going to abbreviate it with W. Work done is equal to the force times the distance. Force is in newtons, and you take care that distance should be in meters. So that means our work done, according to the question that we have, is going to have a force of 60 newtons times the distance in meters, which is 5. And our work done, if we calculate well, will be 300. And 300 has to be put in joules. So that is our example. Force times distance gives us work.
Teacher, why is the answer in joules?
Peyton, you're asking why the answer is in joules?
Why the, yeah.
Yes, we said in our slides that we had here, that I think Bridget is the one who read for us. He read for us that work is defined as the product of force and distance moved in the direction of force, and the units for work are joules. The units for work are joules. So that is why we are writing our answer in work for joules. Okay? Peyton, yes. That is why our answer is in joules, not in any other units. Okay?
Yes.
Okay, can some other person read for us example 2? Can someone read for us example 2?
Town B and town C are 200 meters and 500 meters away from town A respectively. Car moves from town A to town B before reaching town C. If its engine does work to 1.5 million joules to move from town B to C, what is the driving force of the engine?
Can you read for us again a little? Can you read for us again, Angel?
Town B and town C are 200 meters and 500 meters away from town A respectively.
Yes.
A car moves from town A to town B before reaching town C. If its engine does work of 1.5 million joules to move from town to C, what is the driving force of the engine?
What is the driving force of the engine? Okay, now that is our second example. They have told us that there are towns. We have town A, there is town B, and there is also town C. they have told us that town B, the distance between town A and town B is 200, whereas the distance between town A and town C is 500. And that distance is in meters. They told us that a car moves from B to C, and the work that is done there is 1.5 million joules. So they are asking us, what is the driving force of the car? What is the driving force of the car? So I've tried to summarize our question in that diagram. Anyone who can help Jojo to put her microphone on so that she can hear us, because she's not hearing us well. According to what I see, her microphone is off. So you help her well as we continue with our question here. Now, we are having, from what we know that if I'm to get work, I have to have a force times a distance. Please don't annotate. Don't do anything on my whiteboard because you are distracting me. Don't do anything on my whiteboard. Just focus and understand your question. Understand the question that you are discussing. Now they are giving us. They have given us work. They told us work is 1.5 million. And if I'm to write 1.5 million, it is 1.5. So 1.5 million is our work. 150 0 1 2 3. So that is our 1.5 million. That is our work. And that work is equal to, remember they are asking for a driving force. We don't know the driving force. And the distance that we are considering is the distance that they have told us in which work is done, the distance between these two towns, B and C. So anyone to tell us what is the distance between the two towns B and C, according to what you see in the diagram?
300 meters.
Okay, someone is telling us 300 meters. The distance between town B and C is 300 meters. That means we are going to have our force times 300 meters. And it means that if we divide through our 1, 0, 0, 1, 2, 3, is going to be equal to 300 times F. If we divide through by 300 on both sides, we'll be having our force F being equal to
5,000 newtons.
So we'll be having this one cancelling, this cancelling with this one cancelling with this. If we divide this by 3, it will be 5,000. So our driving force for that example is 5,000 newtons. 5,000 newtons. And that is our answer for our second example. Yes, for my friend who has just come in, we are talking about work, power, and energy. And we defined work as the product of force and distance moved in the direction of force. And the SI units for that work is joules. And we have been doing those two examples. Yes, Hannah? Yes, Hannah.
On that number from doing.
Yes.
That number to the, I did not understand something. Is it 1.5 million or 15 million?
It is 1.5 million. That's why we had 1500 and then the 2 zeros, 3 zeros, which makes it 1.5, eh?
Oh, okay, I understand. Thank you.
Okay, Anna. So those are our examples. Those are our examples. In case you have any question about that, you can be able to tell us if there is any question that you can ask on what we have just seen. You can ask it. Otherwise, we can continue with something else. And that something else is work against gravity. Let me try and... Work against gravity. Is there anyone who can read for us? Nicholas? Nicholas, you read for us. Nicholas Muleme. You read for us.
When a body is work against gravity. When a body is carried vertically upwards through a distance above the ground, work is said to be done against gravity. For example, if a person climbs stairs or if a body is pushed up an inclined plane, we calculate work against gravity from work is equal to weight times distance, where weight is product of mass of a body and acceleration due to gravity.
Okay, thank you so much, Nicholas, for reading for us. They are telling us that we say work is done against gravity if a body moves vertically above the ground. And they have given us two examples. One is, for example, that man you see there, the briefcase moving up a staircase. This man that you see is moving from down here to up here, and the height of the staircase is now the vertical distance moved. And this man here has a weight which comes from mass and acceleration due to gravity. Weight of a person is the mass of the person times the acceleration due to gravity of that person. Okay? Therefore, if they ask you for the work done, in this case, it will be the mass of this person times the acceleration due to gravity, G, and the G is constant. Constant means it is the same if we are all on Earth, it is 10 meters per second squared. So that is a constant acceleration due to gravity. Then times h, which is the height or the vertical distance moved by that person as he moves up. The other example that they have given us is if a body is pushed up an incline. Now, an inclined plane, let us say we have something like that. We have a veranda, which is up. So this is our veranda here. Focus on the red thing alone. Now, if I have to carry something from down here and I'm taking it up here, let me draw it properly. If I have this as my veranda and I want to move something from down here to up here, if you have ever tried it at home, some people put a piece of timber like that, such that if it's a wheelbarrow, it can be driven on that piece of timber. And if it's a box that you want to push, you can also put that box on that piece of timber and you push it. So if this is our box, if this is our box here and we are pushing it up, what we have done here is called an inclined plane. And they are telling us that the force that will take this one up times this vertical distance above the ground will give us the work done against gravity. And that work is also in joules. For example, can we have someone read for us those two examples? Yes, Faith.
Ruth has to attend a physics practical lesson in the lab. She climbs up a staircase of height 5 meters. If Ruth has a mass of 60 kilograms, calculate the work done. Take grams equals 10 meters, I think, seconds per second.
Okay, that is G, which means acceleration due to gravity, not grams. We are taking acceleration due to gravity as 10 meters per second squared. Okay, thank you for reading for us. Let us first do that one. We'll read that one after. So is there anyone who can take us through that example? Is there anyone who can try to take us through that example? We have Ruth. She climbs a staircase of 5 meters. She has a mass of 60 kilograms. They're asking us to calculate the work done, taking the acceleration due to gravity as 10 meters per second squared. Hannah, you want to take us through? Hannah?
Yes.
Yes, can I share the white screen and you take us through?
Okay, yeah.
Have you copied all the details that you will need?
Yes, I have.
Okay. Okay. Hannah, you can use the screen.
Work, I annotate it or?
Yeah, you annotate. It's there. I think you can. You try out and see if you can annotate.
Okay. Work done equals to a mass which was 60 kilograms. Yeah. It was 60 kilograms. And then the acceleration due to gravity was 10 meters per second squared. So, second squared, then times the height. The height was 5 meters. Okay. Okay, I think here I can remove the meters because 5 meters has and even 10 meters, if that is possible. Then I remain.
Okay. Hannah?
Yes, please.
You go on.
Teacher, I think that maybe I remove the what?
The units.
Yes, the
It is
meters.
okay. It is okay. You remove them. You can now focus on the figures only.
Yes.
You focus on the figures only.
Okay, 60 times 10 times 5. That gives me, that will give me 30, that will give me, it is 30 then plus this. Gives me 3,000.
Yes, 3,000 joules. Okay.
Joules. I think it gives me 3,000 joules because I'm calculating the work done.
Okay, thank you so much, Hannah, for that wonderful presentation. There is a with others. Now, Peyton, we said that if we are getting work done against gravity, if you can see well here, we said work done against gravity is got from work is equal to weight times distance. That weight is also a force, where weight is the product of mass of the body and the acceleration due to gravity. So if you want weight and they have given you mass, then you have to get the mass m times g, which is acceleration due to gravity. That's why Hannah has used m, which was 60 newtons, times g, which is 10, to get 600, then times 5, which gave us the 3,000 joules. Hope you have got that, Peyton. Peyton, have you got that well?
Yes.
Yes, that is so good. If you have got that, then let us read through example 2 of what we have there. Example 2. Someone to read for us example 2. Vicky. Vicky.
A box of weight 550 newtons is pushed up an inclined plane. If the work done to push the box is 1,375 newtons, determine the height of the inclined plane.
Okay, thank you, Vicky, for reading for us. Is there anyone who can take us through that example? Like Hannah did. Is there anyone who can take us through that example? No one can take us through the example. Yes, Lam. Yes, Lam, you can take us through. You can unmute. Let me share my whiteboard. Lam, you can use the whiteboard, please, to discuss for us. Can you use a white screen? If not, so then I can choose another person to help us through. I think Lam is, yes, you go on. If you had all the details.
But teacher, which units do they use?
Sorry?
Which units do they use after the calculations?
Now, if they have asked you for work, then the units must be joules. Okay?
Even in
Joules,
when
capital
they say,
J.
Oh, okay. Even in work against gravity.
Yes, even if it's work against gravity, it is capital J. Joules, eh? Okay, is there someone who can do us the example that we put where we had, let me put the example again so that we can read it properly and then we go through it. The example is there, example 2. Example 2, anyone who can read it for us, and then we go through.
A box of weight 550 newtons is pushed up and plane. The work done to push.
Please let one person read. Let one person read. And there is a correction that I want to make here. The correction here is this one is joules. Work done is joules. Okay, Vicky, read for us. Vicky, you read for us.
A box A box of weight 550 newtons is pushed up an inclined plane. If the work done to push the box is 1,375 joules, determine the height of the inclined plane.
Okay, that is the question that we have. So I'm requesting someone to do it for us. Ryan, are you going to do it for us? Okay, Peyton. Peyton?
Yes.
Should I share the white screen and you go through it?
Yeah.
Okay. It is there for you now. You can share with us.
Teacher, I don't have anything that I can use to write on the whiteboard. Hello? Hello. I think we should first give the formula, which is work equals weight times distance. Since we have been given the weight and the work, that means we have to find the distance. So we say work equals weight times distance. So the work is 1,375 joules equals to 550 newtons times D. Since we don't know the distance, then we divide using 550 newtons, we get 1,375 divided by 550 equals 550 D divided by 550. So when we divide this, I think we may get that answer, I'm not that very sure. I'm not that very sure on the answer, but that's the way they do it. Thank you.
Yes. Somehow.
Are you speaking?
Can you hear me?
Okay, that is what our answer is going to be. We have work is equal to force times distance. We have 1375, which is given to us as work, being equal to 550 D. So on dividing through by 550, I'm not sure, but if you have your calculators, I think if you divide 1375, divide by 550, I think you get the 2.5 meters as your distance. Is that what we get if you calculate? Patricia, have you seen how we get the 2.5?
Yeah, but teacher, the question was asking for the height. Then how do you again get the distance, yet it's asking for the height?
Yes, now we said that if it's the, Faith says she has not got, okay. Let me redo this. Now this is our work done, which is force times distance. But they told us that we have a body of weight 550. So weight is a force, that is why I'm substituting 550 where there is F and D. Now the distance in this case moved is the vertical height. The distance moved in this case is the vertical height. Please, if you're not telling us anything, I ask you to mute your microphone. Now, Patricia was asking why we use D, saying distance. Now, this distance is the distance in the vertical direction, which we called the height. So you can, the D that I've used is just, you can use any unknown that you wish. You can use H, you can use D. So long as you have got the correct answer, what we have as the unknown does not matter. So that's why I'm substituting 1375 times D, or let us use H, so that we bring out what they asked us, which is the height of the incline, H. So we are going to have our 1375 being equal to 550 H. So we divide through by 550. We divide through by 550. So that means that our H, which is height, is going to be equal to, when you divide these ones, I think we'll be getting 2.5 meters. 2.5 meters, and that is our height. Okay?
Yeah.
All right. If you have got it well. Okay, that is our answer, our second example. Are we still together? Are we still together? If there is any question, please you ask it. Teresa, I don't know what is wrong, but this face shows that you are not happy with whatever is going on. So you please tell me what's wrong. Okay, we can continue. But before I continue, I want to take you back a little for the definitions. We defined
what
work.
Is a jewel?
We defined work as the product of force and distance moved in the direction of force. And we said its SI unit is joules, okay? And after getting the joules, now some people joined in late and they found us already somewhere. For those who joined in late, I'm trying to summarize what we have been talking about, okay? So you pay attention. We have defined work as the product of force and distance moved in the direction of force. So that means if I'm to get work of something, I have to know what the force is. Product means multiplication and then distance, D. So the SI units for work are joules, and someone asked me what a joule is. Now, if you are to define a joule, you have to get it from the definition of work, where we have said it's force times distance. So if you're defining a joule, you say, this is the work done. Someone can write this definition in the chat as I'm speaking it out. A joule is work done a joule is work done when a force of 1 Newton, a joule is the work done when a force of 1 Newton moves or acts through a distance. When a force of 1 Newton moves or acts through a distance of 1 meter. Through a distance of 1 meter. So that is how we define a joule. Thank you, Nicholas, for writing us that answer. And Tasha, thank you so much also for writing that answer for us. For anyone who needs the definition of joules, it's in the chat. So that is where we started our lesson from, talking about work as the product of force and distance moved in the direction of force. And now, after looking at that, we had examples, and throughout those examples, we were using the formula that I've just shown you, where we have work, W, being equal to force times distance. That is all that we have used throughout our examples. Now, after looking at work in its plain form, then we went ahead and looked at work against gravity. Work against gravity, we said that is when work is done and the body moves from the ground to a point that is vertically above the ground. So in that case, the distance that we talk about is the vertical distance, this distance here. For example, that man that you see, the height of those stairs is what we will take as our distance when we are calculating work. And they have also told us that in this case, the work done is equal to the weight of the body times the distance or times the height through which that body goes through. And they have also told us that our weight is the product of mass of the body and acceleration due to gravity. Acceleration due to gravity is constant. It is a constant. It doesn't change. For all calculations that you'll be doing where you need D, then you just write 10. So that means if I'm to get the work done, I have to get the weight times the height through which the body moves. So that is the work under gravity. And we have also seen examples 1 and 2. I can take you through example 2 here, where we have a box of weight 550 newtons pushed up an inclined plane. If the work done to push a box is that, then they are asking us for the weight. Now you see that in this case, we have the weight, which is now our force, 550. We have our work done, which is 1375 joules, but we don't have the height or the distance. So what you have to do is just to quote the formula. The formula says that our work done is equal to force times distance, or is equal to weight times the height, because weight is a force. So we'll be having our force, 550, times the height that we don't know, which is h. Then the work done is 1375 newtons. So if you divide through by 550 on both sides, you'll be getting your h as 2.5 meters, the height as 2.5 meters. So that is briefly what we have gone through, and I've tried to summarize that. So that is where most of you found us, and I want us to go to this other thing. But before I go there, someone has, is the distance of the stairs vertically equal to the distance the man is moving to go up? Yes, it is. It is the same distance. Because sometimes they give you the height of the staircase, or sometimes they give you the height of each stair times the number of stairs that that person uses. So Jubilant, that answer is a yes. Okay. So that is where we are. Now I want someone to read for us this question. Sorry, this slide. Patricia, your hand is up. You read for us.
If two people P and Q carry a load of 15 newtons through a
Patricia, you have not read us our title. Yeah?
Oh, sorry, power.
Our title is power.
If two people, P and Q, carry a load of 50 newtons through a distance of 10 meters, both of them have done the same work. If P did the work in 20 seconds and Q did the work in 40 seconds, we say that P is more powerful than Q because P uses less time. Therefore, we define power as rate of doing work. SI units of power are watts.
Okay, thank you so much, Patricia, for reading. Someone at this time asking what is the topic. I think that person has just got in. The topic is work, power, and energy. We have discussed through work, and now we are discussing power. We are now discussing power. Power, she has read for us that we have two people, P and Q. They carry a load of 50 newtons through a distance of 10 meters. Both of them have done the same work. Because we said work is 4 times distance. So if they carry the same load through the same distance, that means they have done the same work. But now, if P did work in 20 seconds, whereas Q took 40 seconds to do the same work, then if we are comparing those two people, we will say that P is more powerful than Q. Why is it so? It's because P has done work faster. They had to carry 50 newtons through 10 meters. P took less time. That means he has done the work faster. He has carried the load faster. So that means if we are comparing the two, we'll say, this person P is more powerful than Q. Why do we say more powerful? It's because there is more power that is developed. More power that is developed as this person does work. Therefore, if a person asks you to define work, work will be defined as the rate of doing work. If someone tells us to define power, power is the rate of doing work. Rate means now there is an element of time. You do work, but how fast do you do the work? How fast do you do the work is what we call power, the rate of doing work. And the SI unit for power is watt, which is a capital W. Someone says, teacher, we didn't reach there. Now, all the topics that we're going to be finding in our lessons here at HELP in this new year are going to be new topics. For most of us are going to be new topics. And they are topics that are relevant to the classes that we are going to. For example, work, power, and energy is the first topic that you're going to be looking at in S2. So that's why you want to introduce to you these topics well, so that when you get to school, you are so well conversant with everything that you're going to be finding there. Someone even what we are going to first look at the formula, then we also define it. Someone read for me that formula. How can we define power? How can we determine power? Sorry. Tasha?
formula, power is equals to work done or time taken is equals to work done is equals to force times distance divided by time taken. Maybe it's power.
Okay. So power from the formula, power is equal to work done divided by the time that is taken. That is our formula. Please mute your microphones. Okay. Power, we have said we get it from work done divided by time taken. And you remember that work done, remember we said it's the product of force and distance. So if they give you a force and a distance and time, and they ask you to determine power, you get it from work done over, divide by the time that is taken. That is how we get our power. Now, for those ones who are asking for the definition of a watt, we define a watt as power developed, when a force of ton a distance of 1 meter in 1 second is the power developed when a force of 1 Newton moves through a distance of 1 meter in 1 second. In 1 second. I've said that power, I said that a watt is power developed. Power developed when a force of 1 Newton moves through a distance of 1 meter in 1 second. So that is what we call a watt. That is what we call a watt. Yes, those are examples for power that I have. Someone should read for us. One to read for us, then another one to take us through by calculation.
Calculate the power developed when a force of 50 newtons acts through a distance of 3 meters in 2 seconds.
Okay, calculate the power developed when a force is 50 newtons, acts through a distance of 3 meters in 2 seconds. So I'm going to put a white screen now so that we can go through that. Anyone who is going to take us through? Raise up your hand if you're going to take us through. Yes, Naiga.
Power equals work done divided by time taken, which
yes,
is
Naiga.
Equal to 50 times 3.
First weight is equal to work out of time.
Work,
yes.
Yeah. Which is equal to 50 times 3 divided
50
by
times 3 divided by
2.
Dividing by
time 2. 2.
Divide by 2.
Which is equal to 150 divided by 2.
150 divided by 2.
Yeah, then the answer is 75 watts.
75 watts.
My name is Shanita.
Okay, Shanita, thank you so much for giving us that answer. Someone is telling me, Jaden, what is the problem? Where are you lost from?
Okay, the formula of how to get the power. That's where I'm lost from because I came in late. I had a problem with my connection.
Okay, let me try and rewrite the formula here. Now we said power is equal to work done out of the time that is taken to do that work. So it is work done over time. But earlier we saw that work done is equal to force times distance. So that means power can be got from force times distance divided by the time that is taken. And they gave us force of 50 newtons for that example, a distance of 3 meters, and time of 2 seconds. So if you use that to calculate, you'll be getting power as 75 watts. So you write 75 and a W. Someone is asking what the question is. People, when I put questions as the other person is reading for us, make sure that you write what is necessary. Okay? You write what is necessary. So the examples for that is question 1 is what we are answering. So I'm going to give you 5 minutes and you also copy the example 2 and then we go through example 2 also. Yes, I'm seeing some answers in our chat. People are getting answers for example number 2 where they are telling us that we have a person called Tom, uses a power of 600 watts to climb up a staircase of 6 meters in 5 seconds. And they are asking us that what would be the reading in newtons on a weighing scale if Tom stepped on it. In other words, they are asking us for the weight that Tom has. They're asking us for the weight that Tom has. So if you are to calculate this, the same formula that we saw is the one that you use.
Yes, sir.
The same formula that we saw for power is the one that you are going to use in this case also, where we say that to get power, we get it from, remember we said it's work done over time taken. So it's force times distance over time. Force times distance over time. Now they gave us our power. They gave us our power as 600 watts. So we have 600 as our power. We don't have the force. In fact, it's what we are looking for. Tom's weight. We have the distance as 6 meters, and the time is 5 seconds. So they're asking us to get the F. Now, in that case, we are having our 600 being equal to 6F out of 5. So if I multiply by 5 on both sides, I'll be getting, this side is 3,000 is equal to 6F. And if you divide by 6 on both sides, if you divide by 6 on both sides, you'll find out that your F is 500 newtons. And F being 500 newtons means that is the weight of that person called Tom since weight is in newtons, so our answer will be newtons. All right, after seeing power and doing examples in power, then there are some things that I want to do for me. There is that activity that is there. I want us to copy number 1, number 2, and number 3. Number 1, number 2, number 3, and number 5A. So we are doing these numbers. Number 1, number 2, number 3, and number 5A. I want you to copy them down. Copy them down. I'm giving you 10 is a lot. 7 minutes only. 7 minutes only. You copy the questions first. 10 minutes only. You copy the questions.
Kalali. Kalali.
Yes, I said that we are doing number 1, number 2, number 3, and number 5A only. Number 1, number 2, number 3, and 5A only. You copy those ones. Okay, after copying them down, those are the questions that we are going to try through in our time. You should answer them. Number 1, number 2, number 3, and number 5A. You can answer them one by one. You can do number 1 and we get the answer in 2 minutes, number 2 in 2 minutes, number 3 in 2 minutes, so that we use around 8 minutes to finish all the work. Now we are doing number 1 first. We have a force of 588 newtons acting on a box of 4 meters. Sorry, a box moves 4 meters in 40 seconds. Calculate the power. Remember, we said power is equal to force times distance. over time. We said power is the rate of doing work. And we said the way we get power from work done over or divide by the time taken. And remember, work done was force times distance. So if they ask you for the power, you can get force times distance, then all over the time that is taken, like we saw in our formula. So I'm seeing people getting number one as 58.5. That means you got 588 times 4 divided by 40. And we're getting 58.8 joules, watts, sorry, as power used. 58.8 watts. Maclean, I don't know what I should summarize for you, but I think for power, after knowing the formula and the SI unit, it is calculation, and that is what we are doing now. You get the force times the distance, then you divide by the time. Okay, let us go to number 2 because we have only 6 minutes for this lesson to get done. Let us go to number 2. Now, my friends were getting 1500. 1500 watts, like Jaden. And I think you saw in the question that what they gave us is mass, not force or weight. So you consider that, please, as you are calculating. They gave us mass, not weight, not force. So that means you have to multiply that mass, like we said, times 10, the acceleration due to gravity, so that it becomes a weight or it becomes a force. Then you put what you have in the formula. So the answer should be 15,000, not 1,500. The answer for number 2 should be 15,000, not 1,500. You check it well. Okay, now for number 3 and number 5A, if you copy the questions, I will do them in your time, and our WhatsApp groups will be open for you people to send me your solutions to see if they are correct. In case of anything, I'll be correcting you. Who is this one? In case of anything, I'll be correcting you. Number 3 and number 5A are the questions that we have not done yet. Otherwise, thank you for showing up for the lesson, and thank you for being a good class for today. I hope you also enjoyed the lesson. Hope you have learned one thing or two. I'm going to send the slides that we have used, and also the questions, so that in our next lesson, we will start from there. For those ones who have not come early today, please come early tomorrow. The timetable tomorrow says we are having S2. This is S4. S2. So S2 tomorrow we are having biology, same time, 2 to 4. 2 to 4, so you please come early so that you don't miss the starting things. I'm going to ask one of you to pray for us as we finish our lesson. One person to pray for us as we finish the lesson. Yes, Martha? Martha?
Humble yourselves and we pray. Heavenly Father, King of glory, we thank you for today. Thank you for the gift of life, for the gift of wisdom, knowledge, and understanding. And as we are living this lesson, Father, we pray that may you bless each one of us who has attended this lesson, Father, King of glory. And above all, may your will be done. Through Jesus, our Lord. Amen.
Amen. Thank you so much.
Amen.
Okay, have a good time.
Amen. So bye.
Bye.
Okay.
Bye. Bye. Jojo.
Ciao. Guys, tell the stomach for us, please.
Bye, everybody.
Now, Vicky, for you, I'm just calling on the Jojo.
Jojo.
Bye.
Bye, Angel.
People.
Bye, Danny Real.
Bye, Victor.
Bye, Nina Massa.
Bye, Natasha. Even though.
Bye.
Bye, Patricia.
Bye, Angel. Bye, Vicky. Bye, everyone.
Bye, Natasha. Natasha, first up your WhatsApp number.
Okay, let me first wait.
What?
I'm going to tell seat,
Oh, okay, in the chat.
Okay. Hey, who's this girl?
Which one? Hey.
You people, bye.
Christy.
Wakaidu kida.
Mama.
Oh.
You people, I'm leaving. Bye.
You
bye,
go.
You go.
Mama.
Hey.
We are chasing you.
Let her go. Waiting.
But you guys know the school you went from.
Natasha, why are you raising your hand? Teacher, bye.
Teacher, bye. See you next lesson.
When?
Tomorrow.
Tomorrow during the bios lesson.
When? Oh, yeah.